morning, ma'am. I am Joanna Nodalo, and this is the report of Group 4. Combined gas law. What is combined gas law? The combined gas law is a gas law that combines Boyle's law, Charles law, and Gay-Lussac's law into one a set of formula in which three variables of a gas, pressure, volume, and temperature, are taken into consideration. Robert Boyle, at a constant temperature, the pressure and volume of a gas are inversely proportional. Jack Charles, at a constant pressure, the volume and temperature of a gas are directly proportional. Joseph Louis Gay-Lussac, at a constant volume, the pressure and temperature of a gas are directly proportional. Combined gas law formula. When working with the combined gas law formula, all pressure and volume units need to be the same, and the temperature needs to be in Kelvin.
What is real-life example of combined gas law? If a balloon filled with helium on the surface of the Earth, it will have a certain pressure, temperature, and volume. If the balloon is let go, it will rise. Further up in the air, the temperature and the air pressure begin to drop.
So this is the formula of combined gas law. P1 stands for initial pressure, V1 stands for initial volume, T1 stands for initial temperature, and P2 is final pressure, and V2 final volume, and T2 is final temperature. And take note, the standard pressure 180 m is equals to 760 millimeter mercury and 101.3 kPa and 14.7 psi. And temperature must be converted into Kelvin. Kelvin is equals to degrees Celsius plus 273.15. Example 1. Combined gas law solve for pressure. A gas occupies 40 L at 180 m and 200 Kelvin. How much pressure will the gas exert if the temperature increases to 400 Kelvin and its volume decreases to 20 L? So the formula is P1 V1 over T1 is equals to P2 V2 over T2. I mean, the given is P1 is equals to 180 m, and ang V1 is 40 L, and ang T1 is 200 Kelvin, and ang P2 is unknown, and ang V2 is 20 L, and ang T2 is 400 Kelvin. So, i-cross multiply ang nako ang formula. So, P1 V1 T2 is equals to P2 V2 T1. So, bring down V2 and T1. So, P2 P1 V1 of T2, and then over V2 in T1. So, P2. So, ang P1 na nato is 180 m, and ang V1 is 40 L, and ang T2 is 400 Kelvin. Over V2 is 20 L, and ang T1 is 200 Kelvin. So, cancelled out. So, 1 times 40 times 400 is equals to 16,000 ATM. And then 20 times 200 is 4,000. So, 16,000 divided by 4,000 is equals to 4 atmosphere. So, the final pressure is 4 atmosphere.